All right, let's look at the sample test solutions for Chapter 3. So remember that there is one omit on this test. So for number 1A, we are doing the definition of derivative the long way. All right, so there's only one of these that we need to do the long way. If you want this to be your omit, you can do that. But we've got our function, and they ask us to find the derivative at 2. And so here is our definition of the derivative. So we're going to start with, go ahead and put, since we're only finding this at one value, go ahead and put 2 in for a here and here. So that would give us f of 2 plus h minus f of 2. All right, f of 2 plus h literally means put 2 plus h in the place of x in the function. So if we put 2 plus h in the place of x, we're going to put it right here and right here. So that's going to be 3 times 2 plus h squared minus 5 times 2 plus h plus 2. 3 times 2 plus h squared minus 5 times 2 plus h plus 2. All right, then we're going to subtract from that f of 2. So if we took 2 and we plugged it in the place of x in this function, that'd be 3 times 2 squared, so 3 times 4 is 12, minus 5 times 2 is 10, so 12 minus 10 is 2, and then 2 plus 2 would be 4. So f of 2 equals 4. And then we're going to divide that whole thing by h. All right, so order of operations, I'm going to square the 2 plus h. Remember, that's 2 plus h times 2 plus h. I have to FOIL that. So if I do 2 plus h times 2 plus h, here's what I get when I FOIL it out. All right, so I have 3 times that FOILed, 3 times that FOILed. And then minus, let's distribute the 5. So negative 5 times 2 is going to be negative 10, and negative 5 times h is negative 5h. So negative 10 and negative 5h. And then plus 2 minus 4, plus 2 minus 4. So now we can just do our distribution in the front here. So we can say 3 times 4 is 12, 3 times 4h is 12h, and 3 times h squared is 3h squared. So that's where we get this right here. All right, so negative 10 plus 2 is negative 8. Minus 4 is going to give us a negative 12. So now if we start combining like terms, 12 and negative 12 will drop each other out. And then 12h minus 5h will give us 7h plus the 3h squared that we still had left. Notice that everything in your numerator has an h in it. So let's factor out the greatest common factor of an h. And then I can cancel that h top and bottom. Remember that I can't cancel h here because you can't cancel things that are being added and subtracted. It has to be something that I can factor out, and then I can cancel it top and bottom. So now what's left is a polynomial which is well behaved. So I can do direct substitution. So I'm going to put 0 in the place of h, and that gives me 7 plus 0, or 7. All right, now let's check that using our shortcuts, and you just need to show a little bit of work on this. So if this is my original function, then using my shortcuts, I can say power rule, 2 times 3 is 6, and then reduce your exponent by 1, so that would be x to the 1, so 6x to the 1, or 6x. And then here, this is negative 5x to the 1, so 1 times negative 5 is negative 5x to the 0. So that would just be negative 5 because x to the 0 is 1. Or you also can remember the derivative of x is 1. So negative 5 times 1 would be negative 5. And then the derivative of a constant is 0. So the derivative of 2 is going to be 0. So we've used our power rule to get our derivative, and then since we wanted the derivative at 2, let's put 2 in the place of x. So if I put 2 in for x, I'm going to get 12 minus 5, or 7. All right, then number 2, it says create the equation of the tangent line for that first problem at x is equal to 0, and we're using our shortcuts. All right, so again, if we want to create the equation, we need a point and a slope. All right, so let's start with our point. They told me that x is equal to 0. They did not give me the y value. So let's go back to our original equation, 3x squared minus 5x plus 2. And if you know x and you want to find y, you just plug in x and you find y, right? So let's put 0 in for x, 0 in for x, and we'll end up with 2. So that's going to be our point 0, 2. Now, when you put 0 in for x, that's your y-intercept, right? So there's b right there. All right, and then to find my slope, remember that slope of the tangent is derivative. So I just need my derivative at the point 0. So we'll put 0 in for x and we'll get negative 5. So now I've got my m and I've got my b. And so that would be y equals mx plus b. So negative 5x plus 2. What if they didn't give me the y-intercept though? If we weren't asked to find this at 0, if we were asked to find it at any other point, we would need to do that a little differently. So let's look at that. All right, so to begin with, they asked me to find the equation of the tangent line at x equals 1. They did not give me the y value. So if x equals 1, we're going to do the same thing. We're going to plug 1 into our original equation. So that's going to be 3 times 1 squared minus 5 times 1 plus 2. 3 times 1 squared minus 5 times 1 plus 2. So when I plug in 1, I get 0. So there's my point for my equation. Now I need a slope, all right? So remember that the slope was 6x minus 5, and we're finding the slope at 1. So we'll plug in 1 into 6x minus 5. So if you plug in 1 into 6x minus 5, there's our 1 in for x. That gives us a positive 1. So now I have a slope of 1 and a point of 1, 0. That is not my y-intercept, right? That's not my b value. So I'm going to come over here and say if y equals mx plus b, and I know my slope is positive 1, then I'm going to plug in the point 1, 0. So I'm putting 1 in for x and 0 in for y, and that will enable me to find b. So if 1 plus b is equal to 0, subtract 1 from both sides, b is equal to negative 1. So then my slope was 1, and my y-intercept was negative 1. So if I do y equals mx, 1x, plus b, b is negative 1, that would be y equals x minus 1. That would be the equation of my tangent line. All right, then number 3, it says, where does this function have a horizontal tangent line? All right, tangent line, slope of the tangent line is derivative, and a horizontal line has a slope of 0. So that means that our derivative will be equal to 0. So let's go through and let's find the derivative of this, and then we'll set it equal to 0. So to find the derivative, remember the derivative of cosine is a negative sign. So we're going to have negative 2 times negative sine, so that'd be positive 2 sine. And then the derivative of x will be 1. All right, so there's my derivative. Let's set it equal to 0 and solve it. Because remember that we said the horizontal tangent line has a slope of 0. We just found the slope of the tangent line, the derivative. So we set the slope equal to 0. And now we're solving. So let's subtract 1 from both sides and then divide both sides by 2. So that'll give us sine equals negative 1/2. Then you can look on your unit circle, which is given to you on the test. Look on your unit circle for where your y value is negative 1/2. And that occurs at 2 places between 0 and 2 pi. That occurs at 7 pi over 6 and 11 pi over 6. All right, then for number 4, they want us to graph the derivative of the function. All right, so there were 3 steps that we utilized for this. Number 1, find your horizontal tangent lines, because as we just saw a second ago, anywhere you have a horizontal tangent line, your slope is going to be 0. So if I identify a horizontal tangent line at -1 and at +1, then that means my slope, my derivative, is going to be 0 at those values. So it's going to be 0 at -1 and it's going to be 0 at +1. So the horizontal tangent lines here are going to give me my x-intercepts here. All right, then we looked at where the original function was increasing and decreasing. So where the original function is decreasing, any slope that you would draw there would be negative. So wherever it's decreasing, that means that my derivative is negative. And then where it's increasing, my derivative is positive. And where it's decreasing again, my derivative is negative. All right, so what I know is that at -1, I changed from decreasing to increasing. So at -1, I changed from negative to positive. Then at +1, I changed from increasing to decreasing. So at +1, I changed from positive to negative. So what I have on my graph over here right now is I have this piece right here and I have this piece right here. So honestly, all I need to know is how high does this come up here? And so that was our third thing, was to plot strategic points. If I want to know the y value at 0, then I'm going to come over here and I'm just going to draw a tangent line at 0. So if I draw a tangent line at 0 and I approximate what that slope would be, to me it looks like that slope is about twice as high. The rise is about twice as high as the run. So if my rise is 2 and my run is 1, then that's going to give me a slope of 2 at x equals 0. So that means that over here at 0, my y value is 2, because the slope is the derivative. All right, so that lets me know how high to come on this, and so then that gives me the graph of my derivative. All right, then for number 5, we want to know where and why the figure is not differentiable. The only things that you have to choose from on this are discontinuous, vertical tangent, derivative from the left doesn't equal derivative from the right. Those are the only 3 reasons that you can give. If you want to be more specific on your discontinuity and tell why it's discontinuous, that's okay, but it's not necessary. So to begin with, let's go through and let's see everywhere it's discontinuous by where I have to pick up my pencil. So I start drawing over here and I have to pick up my pencil at -3. And then I have to pick up my pencil over here at -2. And I have to pick up my pencil over here at +2. All right. So I know there's going to be a problem at -3, at -2, and at +2. I also want to look for anywhere in the graph where I have a corner or a kink. And so I have a corner or a kink right here at +1. Okay, so now we've identified that we have a problem at -3, at -2, at +1, and at +2. So let's go back and let's give the reasons for each of those things. All right, so for -3, the only problem is there's a hole in my graph right there, and so it is discontinuous at -3. So I'm going to say discontinuous at -3. At -2, you'll notice that my graph goes directly vertical. So to draw a tangent line, I would have to draw a perfectly vertical line, and we can't have a vertical tangent because the slope of a vertical line is undefined. So that means that a tangent line there would be undefined, and the slope of the tangent would be undefined, and slope of the tangent is derivative, so derivative is undefined there. Then at a corner or a kink, the derivative from the left does not equal the derivative from the right. The slope from the left would be positive, the slope from the right would be negative. So derivative from the left does not equal derivative from the right. And then over here at 2, we our limit from the left was down here and our